Hi lads, back again there to do another one of these videos, just to go through the work there on the logs worksheet. Okay, so for the first one here, I have 3 to the x minus 1 is equal to 81. Get the ln of both sides, so I'm introducing it there in red, get the ln on both sides. This allows me to bring down my x minus 1, so you bring it down in front, there it is, and then I want to keep my x minus 1 here, so the ln of 3 goes over and divides on the other side. So my minus 1 goes over, becomes plus 1. So I just put all of that into the calculator and I get x is equal to 5. On to question 2. Same story. I introduce the ln on both sides, so that allows me to bring the power down in front. It's your rules of logs. Remember, ln is just a short way of writing log to the base e. So I have my x down in front, so then my ln of 8 goes over and divides on the other side into the calculator with this, and you get your 2 over 3. On to question 3. E to the x is equal to 5. So get the ln of both sides, so you introduce the ln on both sides, and you know that the ln of e, anything to its own base, is always 1, so they kind of cancel each other off, the ln and the e, so you're just left with the x. Okay, so you get x is equal to ln of 5, into the calculator, ln of 5, 1.609. Question 4. Minus 14 plus 3 e to the x equals 11. So first thing is I want to bring that minus 14 over, becomes plus 14. Then I want to move this 3 over to the other side, so it goes down and divides on the other side. Now I can introduce the ln on both sides, so you kind of want to isolate that as much as possible. So introduce your ln on both sides, so you have the ln of e to the x is equal to ln of 25 over 3. So the ln and the e cancel each other off, so you're just left with your x on the left hand side, and I just put this into my calculator, ln of 25 over 3. That should be the ln of 25 over 3, not the ln of 25 all over 3. Okay, if you understand what I mean, the fraction stays together. The ln is kind of is with the whole thing, not just the top line, and put it into the calculator. Okay, you get your 2.12. On to question number 5. So the first thing I need to do is I want to isolate this as much as possible. So I move my minus 6 over, becomes a plus 6. Now I have the ln of 3x is equal to 6. So I introduce an exponential on both sides, the e number there, okay? So I put e and raise these both so that they're powers. Raise them up to be powers, okay? Again, e and ln cancel each other off, so you're just left with the power here. So 3x is equal to e to the 6. Okay, so they cancel each other off, so 3x is equal to e to the 6. And then just bring your 3 and divide down on the other side. Put this number into your calculator, and you get your 134.476. On to number 6. So in the question, it didn't have any number written there, but what we said this morning in our online class was if there's no number there, put a 10. So log with nothing there is the base 10. Then you're using your rule, the base stays the base, and these two switch. So the base is staying the base, so 10 is 10. These two switch, so it's the squared comes here and the 3x plus 1 goes over there, and you just solve that down as normal algebra. Plus 1 becomes minus 1, divide by 3, and you get your 33. On to number 7. So I have the ln of x minus the ln of 3 is equal to 4. Isolate your ln of x is equal to 4 plus ln of 3. Put both e to the power, e to the power. So you can introduce an e on both sides and raise these up to be powers. So e and ln cancel off, so you're just left with x on this side. And this number, this whole thing, I just put into my calculator. Using the second function ln will get you your e button. Over to number 8. 2 ln 3x is equal to 4. First thing to do is remove that 2 over to the other side, goes down and divides. So now I have ln 3x is equal to 2. Introduce an e on both sides, raise them up to be powers. Your e and your ln cancel off, so I'm just left with my 3x is equal to e squared. So x is equal to e squared over 3. Into the calculator again, using your fraction button, you get your 2.463. That was question 8. On to question 9. 5 to the x plus 2 is equal to 4. So introduce the ln on both sides. That allows me to use my rules of logs. So that allows me to bring down my x plus 2, comes down here. Okay, so you're left with ln 5. ln 5 goes over and divides on the other sides. Plus 2 comes over, becomes minus 2, all into the calculator, and you get your minus 1.1386. This is fine to be a minus number because it's just being a power. Okay, if it was a log, you can't get the log of a negative number when you sub it in. Okay, so next one, question number 10, the ln, and this is the one, sorry, a couple of people asked me a question about this, and I did the wrong thing in the class. I told you to take this squared down in front, but that, you'll only get one answer then. So will you use substitution instead? Apologies for that, I didn't have it done out earlier. Okay, so use substitution. So let y equal to x plus 2. Okay, so you're getting the ln of y squared is equal to 6. Introduce an e on both sides. So you introduce your e on both sides then. And I have e, raise them up to be powers. You get y is equal to the square root of e to the 6. So y is equal to plus or minus 20.09. That's important. When you're square rooting, it can be plus or minus. Then go back and see, okay, y was x plus 2. So you leave each one of your answers equal to x plus 2. And that's how the two answers come about. Sorry about that now. Will you go and correct that in your copy, lads? Because I had the wrong explanation earlier. So that's that one. Sorry, question 11 is the last one. Introduce the ln on both sides. That allows me to bring down my minus 3x down in front. There it is. And then your ln 4 goes over, divides on the other side. And then the whole thing is divided by a minus 3. I put the whole lot into the calculator and you get 1/3. Okay, so the important one there to have a look at is question 10. So use substitution. Alternatively, I suppose you could multiply that out and get x squared plus 4x plus 4 and solve it as a quadratic then, would it be? But I think it's just as easy to use substitution. Okay, and question 11 now, when you go to do it, that's actually using substitution as well. Question 12, the next one on the sheet. Okay, thanks lads.